Okay, today we're starting lesson 6.5 and it's on solving proportions. And you have here the definition of a proportion. It's an equation stating that two ratios are equal. You know that ratios are in fraction form and they're two numbers being compared to one another. It looks like a fraction. So now we're just going to take two ratios and we're going to set those two comparisons next to each other, and we're going to compare those two ratios and see if they are equal or not. All right, moving along. You'll remember this slide from the last lesson probably. We had this comparison of number of pounds of coffee bought and the cost. And how do we find the unit rate once again?
You put
Right. Well, we need to find it to have a unit rate. You need to have one on the bottom. That's right. So what goes on top always?
money.
Money always goes on top. So we're going to set 3 over 1, and that's already in a unit rate. Okay, so if I take 6 over 2 and I make it into a unit rate, I just do the division. 6 divided by 2 is 3 over 1. Well, that's the same cost. It's $3 per pound, no matter how much I buy. And so is it okay for me to do this then? I take 3 over 1. Is it okay for me to write it equals 6 over 2? This next one, is that true?
Yeah.
If we graph those two values on a number line, they're going to be on the same spot, right?
Yep.
Is it okay for me to say that it also equals 9 over 3?
Yep.
Sure. And it also equals 12 over 4? Okay, all of those are equal. They're all graphed at the same spot on the number line. They're the same value. So this is a proportional relationship. We've already talked about that in the last lesson. And the reason that it is proportional is because every one of the rates is equal. All right. The property of proportions. You guys know I like properties, right?
Yep.
So this is probably something important that you want to write down. I'm just thinking. You might see this again sometime. Property of proportion states that the cross products of a proportion are equal. What are cross products?
Oh, I forgot. Wait. I forgot.
Cardi.
Like on this one, it'd be like 2 times 5 and 1 times 10 is like the multiply in diagonals.
Okay, multiplying in diagonals. That's right. So we're going to cross and find the product. And when you're finding a product, it means you're going to multiply. So 2 times 5 is 10, and 10 times 1 is 10. Now we already knew this was a simple example. 1/2 is the same thing as 5 out of 10, 5/10. But this shows us mathematically that they are equivalent, and we can put an equal sign between those two. Okay? So if the cross products are equal, then you have a proportion. If the cross products are not equal, then it is non-proportional. And we're going to look at a few more examples. Determine if each set of ratios is less than, greater than, or equal to. And we can use cross products very quickly to determine what sign we need to use. We've got, there we go, that looks better. If we use cross products, 3 times 30 is 90, and 5 times 18 is what? 90. So what sign goes between these two ratios?
Equal.
Equal sign. 38 times 45 is?
710.
700, what?
1,710.
1,710. And 95 times 18?
1,710.
1,710. So again, we have an equal set of ratios. They are proportional. How about 275 times 452?
124,300.
124,300. How about 3,000 times 40, 25 points?
127,050.
127,050. Okay, so these are not equal because the two numbers that we multiplied our cross products are not equal. And now we have to determine, do we need a less than or a greater than sign? Since it came out as, when you do your cross products, make sure that you write them correctly. Since the cross products came out in these places, it'll be greater than. Since this number is greater than that number, that means this ratio is greater than this ratio. Okay? Now, you want to be in the habit of doing your cross products from the bottom up like this, because if we switch them and go from the bottom down, then you end up with numbers in the wrong place and your signs don't match. So do it from the bottom up when you do your cross product. All right. There's another way, by the way, that we can show that our answer is correct. If you just take this, 42 divided by 275, give me the first three digits of the decimal.
Um, 152.
0.152 and 452 divided by 3,025, first three digits.
149.
0.149, and 0.152 is larger than 0.149. So we just showed in decimal form, we've confirmed that our cross products gave us the correct answer. Okay? All right. Next, we're going to use the fish method to solve for the missing values. We've already used the fish method, right? And so all we're doing is setting up proportions and finding the missing value. Remember how the fish method works? Where do I start?
Opposite of the variant. Yeah.
Find the variable. There it is. Start with the number that's closest to it. 4 is closest to it. 4 times 15 divided by 20 equals x. So x is 3. Find the variable. There it is. Start with the number closest to it. 6.8 times 50 divided by 3.4. Sorry, divided by 34.
10.
Y equals 10. Start with 8.5. 8.5 times 42 divided by 51.
7.
M equals 7. Okay, that's pretty simple, isn't it? Any questions on the fish method? All right, we can also use proportions to solve word problems. The wait time to ride a roller coaster is 20 minutes when there are 160 people in line. At this rate, how long is the wait time when there are 220 people in line? Well, let's set up a ratio given the information that we know. So where does time go on a ratio?
Bottom.
On bottom, so 160 over 20. And we know it's going to be a proportion, so it's okay to put an equal sign. And then I have one more piece of information. Where does 220 go?
Top. No, bottom.
Top.
Why does it have to go on top?
Yeah, it goes on top
160
of
people.
Because 160 is people, and if we're going to set up a ratio that is equal, then 220 has to go on top. Plus, we're looking for a missing value down here, and what is that going to represent?
The time.
Time, so time has to go on bottom. So here's the variable, start with 220, 220 times 20 divided by 160,
27.5.
27.5 minutes, 27 and a half minutes in line. Okay, let's look at another example. We're going to do two different methods to solve parts of this problem. John paid $49.95 for 5 DVDs at a sale. Write and solve a proportion to find the cost for 8 DVDs at the same rate. So we're going to do a proportion for this first one. Money goes on top. Whoops, $49.95 over what? 5, and set it as a proportion. And what goes on my next part here?
8 goes on bottom.
8 has to go on bottom, and we're looking for the price up here on top.
79 and 92 cents.
8 okay, so x equals 79.92. 79.92. All right, now part B, this is going back to what we did in the last lesson, lesson 6.4, where we're setting up an equation. Write an equation relating the cost C to the number of DVDs D. So the cost C is going to equal something related to the number of DVDs. And what was the equation where we used K? What was that equation? Y equals KX. Okay, well, it turns out they don't always have to be a Y and they don't always have to be an X. We can use other variables in there. So the cost of the DVDs equals our K value times the number of DVDs that we buy. Now, how do you find the K value? We've been doing it all along.
Unit rate.
Unit rate is the K value. So K equals, how do I find a unit rate in this problem? Up here at the top, use this information. How do I find a unit rate?
Maybe
49.95 divided by 5. That's going to be my K value. K equals,
Oh, so that's
9.99.
$9.99 per DVD is what he's paying. So now, this equation, C equals K times D, I would just replace the K. C equals $9.99 times D. That is the equation. So it says write an equation. I've done this part. Okay, now how much would it cost for 11 DVDs at the same rate? So cost equals $9.99 times 11. $109.89. Okay, now could we have used the proportion method, the fish method, to find the cost of 11 DVDs?
Yeah.
Okay, which method do you like better? This
I like fish.
writing the equation of the fish. Fish method is much easier, but we still need to be able to do this one because I know what's coming next, right? In chapter 8, we're going to be graphing these kind of equations, and you can't graph these as easily, and you can't do what we want to do with graphs with this method. We want to be able to graph this method. And by the time we get to graphing, once you guys learn how to graph these are easy to graph. They're real easy to put on a graph. It would be much more time consuming to try to graph these. Okay? So, we need to know how to do this equation. All right, here's your homework. Yep, it's a worksheet.